Open bridge designer, modeling, analysis, and detailing for bridges. Look, sometimes we are too busy. We are trying to just keep doing what we're doing. And when we are presented with new solutions, new methodologies to apply to make our work more efficient, we just ignore it because, hey, we're too busy. So, yeah, there is a very inefficient teams there. If we keep that same mentality that what we were doing for the past 10, 15 years, it still works. So why change it, right? On top of that, there is no collaboration or very limited collaboration. Right? So again, talking about bridge design, bridge analytics, roadway geometry, how we communicate among each other, drainage, how we send the information to our drainage engineers on the roadway, on the bridge side. So collaboration is very limited too. And then on top of that, what we do with all the information. Where are the final plans of that particular bridge? We just don't know, right? So not only we lack of collaboration, but as well, there is a lot of data loss, right? Do you know what a microfilm is or microfiche? Do we have plans stored in that way as well? Where is all that information? So there is a lot of data loss right there. So we're trying to switch from 2D plans to 3D intelligent models. We have to recognize that we are still using our Autodesk, AutoCAD, or Bentley's MicroStation, right? CAD software, advanced software running in powerful computers. And at the end of the day, it's just another drawing board that we can easily erase, undo certain commands. But at the end of the day, it's a drafting board that we don't use pen and paper. We use a mouse and a printing machine, right? When we switch to a 3D model, we want to make this model fully parametric. Any changes that we made will reverberate along the 3D model that we're trying to create. 2D drawings are just standalone and intelligent files, are left to the interpretation of the professional eye of the engineer. But regular people doesn't understand that, right? With a 3D model, the model has information. Just the visual itself conveys to the general public what we're trying to achieve, how this bridge, in our case, will be impact the neighborhood, right? How it's going to be the aesthetics and all of that. That is really hard to see on a 2D plan. Top of that, the 2D drawings are human readable, prone to errors, I would say, in which manual data entry is required for analysis as well. On a 3D model, the idea is that the model it's computer readable. And then direct analysis is possible. I don't need to transfer to recreate to another model. The 3D model itself should be able to perform all these activities. With 2D plans, of course, coordination is difficult. Who has the latest version? Did we print the latest version? How we send that information? In an email, FTP site? What's the other softwares? We transfer? Do we have SharePoint? Do we have all that coordination set up? Or everybody does it the way they see fit? So there is no specific source of information in which we need to find all that we need. On a 3D model, the answer is simple. You want data, you want information, you want drainage data, bridge data, geometry data, all of them is on the 3D model. Go to the 3D model, grab it from there. 2D plans, manual checking. Yeah, yes, we have to recognize we have now software that can do that, that can do this manual checking on a PDF document. You may have used some of them. But again, it's still manual checking, right? Some time ago, what we use what? Red, green, and yellow pencils. We color the plans to see, of course, red is an error, highlight is that I fixed the error, and green, somebody check that fix. We do that now with software in our computers, but it's still the same. It's manual checking on 2D plans, right? Checking for conflicts, manual calculation to check clearances. With a 3D model, that checking is automatic. We can do utility conflict checking, clearance verifications, automatic on the 3D model as well. Now, we need to do, for example, rebar cutting. Use the rebar cutting machines. Optimize the cut of rebars. With a 2D plans, there is no way to do it. On a 3D model, if we do full rebar detailing, that automation allows us to optimize the use of bars and send it to, for example, the rebar cutting machines. So what we need to do in general is we have to increase the efficiency on our teams. For design and construction tasks, design build projects, that basically when you are designing, they are already clearing the site. So we need to be more efficient. We don't need to wait for information. The bridge engineer usually sits tight until maybe the 30% of plans on roadway are done, so he can get that geometry, alignment profile information, so he can start placing the bridge. Of course, that will improve the collaboration between all the different disciplines. I'm not talking just roadway and bridge. What about drainage, geotech? All that disciplines need to be coordinated, utilities, landscaping as well. At the end of the day, when these plans, 3D models, all that information is done, especially all the information in which my 3D model is fully enriched, I should be able to use it for the next phase on the life cycle of my structure, meaning operations and maintenance. I don't need to go back to a set of plans and try to review what amount of rebar was used. It all should be on the 3D model that my computer can read. And why is that? Because again, now everything is about 3D digital project delivery. That's what we're trying to attempt right now. Rather than have plans after plans. A typical bridge could be 300 plans, for example. I should have it all that information in a 3D model. Not trying to find sheet 300 in which section of that pier is drafted. Go into that pier, be able to select it with my mouse and be able to see, quantify the amount of reinforcement that is inside that pile, for example. And the industry is moving into that direction. ASHTO has two pool funds. One is for what they call bridge for transportation or bridge for infrastructure, in which all transportation is included, bridge, tunnels, ports, roadways as well. But there is also another one dedicated for bridges, right? In which, again, a lot of DOTs participate. Florida, New York, Texas, all are participants into that pool effort, right? Try to do BIM for bridges, building information model, how to apply this methodology on the projects that we're doing today. Of course, with the Bentley solutions that we're presenting here, this is all the solutions that we can use for transportation on the different parts of a project lifecycle: plan, survey, design, execution, inspection, and maintenance. And all that information could be managed into common data environment that is called ProjectWise. What we're going to be seeing in this class is, of course, the use of OpenBridge. Apart from all the open applications that we have, Open Roads, Open Rail, as I said, OpenBridge is the purpose of this class. And then as well, there is also Open Tunnel for tunnel projects. Again, these are not modeling softwares. They are specific solutions for the type of projects that we're trying to do, right? And this solution for us is called OpenBridge Designer. Why OpenBridge Designer? Because OpenBridge Designer is divided into segments, I would say. One is the bridge model. That's what we're going to do. How to model a bridge, how to create a 3D model of a bridge. That solution under bridge modeling is OpenBridge Modeler. On the other hand, when the 3D model is finished, we go to the analysis and design. On analysis and design, depending on the type of bridges that we do, it could be leverage concrete, bridge press girders, leverage steel, steel eye girders, steel tops, on and we use Iron Bridge if there is a need for more complex analysis, and all the other type of bridges, suspension, cable stay, arch bridges. But the solution in general that allows us to create a 3D model of a bridge is OpenBridge Designer. Why that? Because we got to recognize that we have been using a disconnected 3D bridge workflow. Of course, we're trying to patch it up using software. But again, we use software to do roadway geometry, alignment profile, super elevation. But this software sometimes is not compatible with the bridge solution that we're trying to use. So we need to do a format exchange. On whatever risks this format exchange may bring to us. No? Interpretation of the geometry, we have to double check, is the format correct? How we transfer the spiral properly to a bridge? All of that definitions we need to change. And we need to check as well because of that format exchange that we need to achieve if we want to create parametrics of our bridge because we're trying to use modeling applications. Again, I'm talking about patching up uh, software that we already have, right? And trying to make it parametric using modeling applications, sometimes not even designed for bridge, but general modeling applications, and trying to achieve some parametrics using some visual scripting or visual programming, right? And with all of that, create a physical model. All that information that is exchanged, that is compiled, needs to be managed. And we use kind of a document and content management software for that. But that's not the end of it. Why we do with the physical modeling? Oh, yeah, we need to do clearance verification, verify for conflicts. So, well, there is that physical model needs to be to a format exchange because there is another software that maybe I need to use for constructability review. Oh, I want to do analytics. So, well, another format exchange, or maybe even worse, create another 3D model to perform analytic calculations. I need to do drafting. So maybe another format exchange. Maybe even reduce the intelligence of the model because we're going to the plans now. And then create a 3D digital delivery, right? PDF document. That is not digital delivery. The delivery is digital, but it's not the intent, right? In a PDF document, there is no intelligence. 2D plans, right? You have to recognize it's like printing on paper. Now, not only that process, it's kind of complex, but there are many different software solutions that we need to use, trying to replicate the process that we're using, or we were using for the past 30 years. The attempt is now to do an integrated workflow. Open Roads in Bentley is the roadway geometry solution. That information is being read. I'm not saying format exchange, it's being read in native format by Open Bridge Designer. That's the solution we're studying today. And with that, we create a 3D model. That solution runs on top of a CAD platform of Bentley, MicroStation, right? That is our platform. Then, taking advantage of that platform, we can create 3D visuals, animations, right? So the general public can see how the bridge will look like, for example. the impact that it's going to have in the community. With that same 3D model, I can do analytics, I can do design, having information, just basic information in the 3D model, like materials and pricing. I can do quality reports. I can do a preliminary budget if I want. Having the 3D model, I can do to do I can do 3D rebar detailing. Having that 3D model, then I can also cut plans. Well, we need to sign something, right? And then all that information, maybe some details into the full 3D model with all the information needed, is sent to construction in many different forms, right? In general, we could send as a digital twin. In Bentley, it's called the I-twin. So the 3D model becomes the legal document. The acronym is BALD, model as a legal document. That is the solution that we're studying today.